Fill in the boxes with the correct numbers according to the rules. In Lessons 1 and 2, we narrowed down the choices by finding common numbers in the row and column number sentences. In Lesson 3, both rows and columns remain the objects of observation. When examining a single box from two directions at the same time, a range of allowable numbers emerges for each direction. When the minimum value from one direction and the maximum value from the other direction point to the same number, the number for that box is determined. Finding common numbers and comparing minimum and maximum values are ultimately the same process. The principle of observation, examining everything that influences a box and narrowing down the choices, remains unchanged. The teacher should not use the terms minimum value and maximum value before the student feels the need for them. The moment the student says, "It doesn't work because it's too small," or "It's too big," the teacher should introduce the terms. Please maintain the format of stating a claim and a reason in this lesson as well.
I found the unique number combinations first. They are 4, 17, 23, and 24. Since the 23 line and the 24 line cross each other, I will try to figure out 6, 4 first.
Go ahead.
There are two common numbers, 9 and 8. I can't figure it out yet.
What should we do?
I'll just try putting in 9 first. Then 7, 4 is 8, and 8, 4 is 6. If 8, 4 is 6, then 8, 3 becomes 1. Because 7 minus 6 is 1, and 7, 3 becomes 8 because 9 minus 1 is 8. Huh? There are two 8s in row 7. It's a duplicate.
Then what?
I have to change 6, 4 to 8. Then 7, 4 is 9, and 8, 4 is 6.
So you mean when you arranged the 23 line as 9, 8, and 6, there was a duplicate, so you changed it to 8, 9, and 6. Let's put both choices side by side and compare them. Did anything stay the same?
8, 4. It is 6 in both choices.
In that case, shouldn't you have figured out 8, 4 first?
8, 4 is influenced by the 23 line and the 7 line. 23 is a unique number combination, but 7 has a lot of choices, doesn't it?
How many?
There are 3 ways: 7 equals 1 plus 6, 2 plus 5, and 3 plus 4. I don't think I can figure out 8, 4 with this.
Try comparing the column combinations and row combinations yourself.
23 equals 9 plus 8 plus 6, and 7 equals 1 plus 6, 2 plus 5, 3 plus 4. Oh! The only common number is 6.
That's right. So you did need to figure out 8, 4 first.
But why? There are 3 different row number sentences, so it's weird that there is only one common number.
Look at the column 23. There is a number that absolutely cannot go into 8, 4. What is it?
1? If I put 1, the other 2 boxes get too big.
Can you explain exactly how they get too big?
If 8, 4 is 1, the sum of 6, 4 and 7, 4 has to be 22. Since the biggest numbers we can put in 2 boxes are 9 and 8, it's impossible for the sum of 2 boxes to be 22.
Then what number do we have to start with for 8, 4?
It has to be at least 6.
Let's call that the minimum value for 8, 4 is 6.
Yes. That means the same thing.
This time, look at the row 7. What happens if you put 9 in 8, 4?
The sum of the two boxes is 7, so I can't put 9 in one box. That doesn't make sense.
Then what is the biggest number that can go into 8, 4?
8 doesn't work, and 7 doesn't work either. Because 8, 3 can't be 0. So it's 6. That works because 8, 3 becomes 1.
A number bigger than 6 cannot go into 8, 4. Let's call that the maximum value for 8, 4 is 6.
Huh? You just said the minimum value was 6 earlier.
Looking at the column, the minimum value is 6, and looking at the row, the maximum value is 6.
It can't be bigger than 6, and it can't be smaller than 6, so there is only 6.
So 8, 4 is 6. Can you explain how you figured out the number for this box?
Looking at the column, the minimum value is 6, and looking at the row, the maximum value is 6. The ranges from both directions point to the same number.
Try to find a box in this practice problem that you can figure out using the method we just used.
The box where 11 and 15 meet has a lot of numbers that can go in. I'll look at the box where 3 and 7 meet. Since it's the 3 line, it is 1 or 2. But looking at the row, it can be 1 and it can be 2, so it doesn't narrow down the choices.
What about the box where 3 and 11 meet?
Since it's the 3 line, it is 1 or 2. The maximum value for 2, 2 is 2.
What if you think about it being the 11 line?
I don't think 2, 2 can be 1.
Why?
If 2, 2 is 1, then 2, 3 becomes 10. We can only put in single-digit numbers, so that doesn't work.
Then what number can go into 2, 2?
At least 2 has to go into 2, 2. That way, 2, 3 becomes a single-digit number. The minimum value is 2.
That means the maximum value is 2, and the minimum value is also 2 at the same time.
So 2, 2 is 2. It's for the same reason as 8, 4.
You can figure out 3, 3 the same way.
Since it's the 7 line, a number smaller than 7 has to go in. The maximum is 6.
It is also the 15 line.
Then small numbers like 1 and 2 can't go in. It has to be at least 6 so that 2, 3 can be a single-digit number.
Now compare the ranges from both directions.
The maximum is 6, and the minimum is 6, so 3, 3 has to be 6. 8, 4, 2, 2, and 3, 3 all use the same principle.
Can you explain what they have in common in one sentence?
Looking from one side, it's the minimum value, and from the other side, it's the maximum value. If they both point to the same number, that box is figured out.
Go back to the original problem and try to find a box where you can use the same method.
I'll look at 3, 2 where the 24 line and the 10 line meet. 9 doesn't work for 3, 2.
Why?
the column sum is 10, so if 3, 2 is 9, the remaining two boxes become 1 and 0. 8 can't go in either.
Why doesn't 8 work?
8 plus 1 is 10, but we can't use the same number twice. So the maximum value for 3, 2 is 7. Looking at the 24 line, the smallest number among 9, 8, and 7 is 7, so the minimum value is also 7.
Can you tell me your answer and explain why?
3, 2 is 7. Because looking at the 24 line, the minimum value is 7, and looking at the 10 line, the maximum value is 7, and the only common number is 7.
And next?
I'll compare the 24 line with the 11 line. In the 11 line, if 3, 4 is 9, the remaining two boxes have to be 1 plus 1, so that doesn't work. If it's 8, the remaining two boxes become 1 plus 2, so it works. The maximum value for 3, 4 is 8. In the 24 line, since we put 7 in 3, 2, the remaining numbers are 9 and 8. So the minimum value for 3, 4 is 8.
Can you tell me your answer and explain why?
3, 4 is 8. Because looking at the 11 line, the maximum value is 8, and looking at the 24 line, the minimum value is 8, and the only common number is 8.
Once you figure out 3, 2 and 3, 4, you'll be able to find the neighboring boxes like a domino effect. Take your time and figure out the remaining boxes. Was there anything memorable about what we learned today?
It was amazing that from one side it's the maximum value, but from the other side it's the minimum value. And it was fun that we could figure out the box by comparing the ranges from two directions.
An amusement park got a new ride. This amusement park only allows kids up to 10 years old to enter. But the new ride is hard to control, so they say you have to be at least 10 years old to ride it.
Then only 10-year-olds can ride it.
Why is that?
There are two rules, one is a maximum of 10 years old, and the other is a minimum of 10 years old. Because they both point to 10 years old.
It has the same structure as cross-sum, right?
Yes. In cross-sum, the row and column are the two rules, and for the ride, the age to enter the park and the age to go on the ride are the two rules.
What we learned today is also observation in the end. We examined both directions that influence a box and narrowed down the choices by comparing the ranges allowed by each direction. But why? There are 3 different row number sentences, so it's weird that there is only one common number. This question from the student is the starting point that leads to the concept of minimum and maximum values. Accepting the result without knowing the reason is entirely different from discovering the reason. How has the method changed from Lesson 1 to today? Finding common numbers, domino effect, comparing minimum and maximum values. If the student can state this progression on their own, the 3 lessons are successfully connected as one.